Hello, you are welcome to another episode on Thomas Academy. Today, we're going to be talking about atomic structure and bonding. Under this, we're going to discuss about atomic structure and electronic configuration. Learning outcomes. At the end of this lesson, learners will be able to define the concept of electronic configuration, write the order of electronic configuration, deduce the number of protons, neutrons, and electrons from atomic and mass numbers of an atom. This is a starter video on atomic structure. Atomic number and mass number. What is the difference between atomic number and mass number? Atomic number of an element is the number of protons in the nucleus of its atom, while mass number or atomic mass of an element is the sum of the number of protons and neutrons in the nucleus of its atom. Mass number is equal to number of proton plus number of neutron. Look at the example below. An element X can be represented as this, where A is the atomic mass or mass number. This at the top is representing the mass number, while the Z below, the subscript, is the atomic number. Example, calcium. Calcium has atomic number of 20 and mass number of 40. I hope this is clear. The structure of an atom. Every atom has nearly all of its mass concentrated in a tiny region in the center of the atom called the nucleus. The nucleus is located at the center of the atom. The nucleus is made up of particles called nucleons. There are two types of nucleon, protons and neutrons. Atoms of different elements have different numbers of protons. Outside the nucleus, particles called electrons move around in region of space called orbitals. The diagram is below. So let's talk about the nucleon number. The nucleon number is the number of protons plus neutrons in the nucleus of an atom. This is also known as the mass number. For example, an atom of aluminium has a nucleon number of 27 and a proton number of 13. So an aluminum atom has 27 minus 13, that's 14 neutrons. I hope this is clear. So this is the model of a carbon atom. You can see this region is called the orbital. So we have the electron located here. The electron is located outside of the what? Outside of the nucleus. Then in the nucleus, we have the proton. You can see the proton and the neutron. We have the proton and the neutrons. And you can see this circle, they are the electron shells, the energy level. I hope this is clear. Electron configuration. Electronic configuration is the arrangement of an electrons in energy levels around an atomic nucleus. Each neutral atom has a number of electrons equal to its number of protons. What we do now is place those electrons into an arrangement around the nucleus that indicates their energy and the shape of the orbital in which they are located. Here is a summary of the types of orbital and how many electrons each can contain. As we can see in this summary, the principal energy level, n, we can always get the maximum number of electrons using this formula, 2n raised to power 2. So we can get the maximum number of electrons. If n is 1, then maximum number of electrons will be 2. N is 2, maximum number of electrons will be 8. When n is 3, maximum number of electrons will be 18. And the number of orbitals per level are given. So using the chart above, we can see that 2 electrons are needed to fill an s orbital, which means an s orbital can contain maximum of 2 electrons. P orbital can contain maximum of 6 electrons. 10 electrons to fill a d orbital and 14 electrons to fill the f orbital. But what we are going to discuss is how these orbitals get filled, the order of fill, and this is very important. So let's talk about order of fill. The order in which electrons are placed into the orbital is based on the order of their energy. This is referred to as the Hufbauer principle. The lowest energy orbitals fill first. Just like the quantum numbers themselves, this order was determined by calculation and is summarized by the following chart. You can see. So this is the order. So this energy level will be filled first before going to this. And this can take maximum of 2 electrons. This also can take a maximum of 2 electrons. And this also can take maximum of 6 electrons. So this maximum of 2 electrons. So this is the order. How to write an electron configuration. The symbol used for writing the electron configuration starts with the shell number n, followed by the type of orbital, and finally the superscript indicates how many electrons are in the orbital. This showing how many electrons are in the orbital. And this is indicating, it's talking about the row. So, and this is the Schwarzschild shell. Periodic properties. One of the real cool things about electron configuration is their relationship to the periodic table. Basically, the periodic table was constructed so that elements with similar electron configuration will be aligned into the same groups. That's column. As you can see, the group 1 element. The group 1 element, so they have 1 valency electron, while the group 2 element has 2 valency electron. Bivalency electron it means that the atomos numbers of electrons in a particular atom. All group 1 element has 1 valence electron, and this 1 outermost electron. And all group 2 element has 2 valence electron, like that. Group 3, 3 valence electron, group 4, 4 valence electron, respectively. Example. What is the electronic configuration of oxygen? Solution. From periodic table, oxygen has 8 electrons based on the order of fill above. These 8 electrons would fill in the following order. That's 1s, 2s, and then 2p. If you look at the above chart, so it will follow this order: 1s, 2s, and then 2p. So s can occupy maximum of 2 electrons, can stay in x, a maximum of 2 electrons here too. Now oxygen has 8 electrons. So if we have 2 electrons here, 2 electrons here, that's 4. And remaining 4, of course, the remaining 4 electrons can stay in the p orbital, since p can contain maximum of 6 electrons. What is the electronic configuration of sodium? From periodic table, sodium has 11 electrons based on the order of field above. These 11 electrons would fill in the following order: 1s, 2s, and then 2p, then 3s. So sodium electronic configuration would be 1s squared, 2s squared, 2p6, 3s1. If we calculate all these electrons, the powers are the electron in the sodium atom. So if we calculate all these electrons, the powers, it must be equals to 11. 2 plus 2, 4 plus 6, 10 plus 1, 11. I hope this is clear. This order is the order that we follow, and it is gotten from the chart above. It is gotten from this chart here, this chart. I hope we understand what we are doing. This chart: 1s squared, 2s squared, 2p6, 3s squared. The order, like orders in that order. So let's continue from where we stop. So, test your understanding. So I believe with what we have discussed, you should be able to solve this question. The electronic configuration of nitrogen is, so the electronic configuration of nitrogen is what? Nitrogen has how many electrons? That's the first thing, the question you should ask yourself. You should know the atomic number of nitrogen to know the number of electrons in the neutral atom. Think about that. What is the solution to question 1? Then question 2, what is the electronic configuration of oxygen? Electronic configuration of oxygen, we've done this. How many electron is present in oxygen atom? That's first question you should ask yourself. Then, if you don't know the answer to this, then you have the solution here. Now look at this. So, this is the order of field. This s subshell orbital will contain maximum of 2 electrons, and this maximum of 2 electrons. So, and this 2p. P can take maximum of 6 electrons, that's 2, 2, 2. But because we have 3 electrons remaining, so the electron will be filled in this order. So the same thing with oxygen, we are going to have maximum of 2 electrons here, 2 electrons here. So this is the order of field 2, because we have 4 electrons left in oxygen, so the electron will enter singly, as in 1 electron first, 1, 1, then pairing will now start to occur, which with the 4th electron. So we have come to the end of today's lesson. In this lesson, you have learned that electronic configuration is the arrangement of electrons in energy levels around an atomic nucleus. The atomic number of an element is the number of protons in the nucleus of its atom. And while mass number or atomic mass of an element is the sum of the number of protons and neutrons in the nucleus of its atom. So thank you for joining us on today's episode on Thomas Academy. Do not forget to do your assignment. Don't forget to do this assignment. And by the special grace of God, I will see you in the next episode. Thank you.